We'll start diving in. So law of sines. So let me give you the law of sines. And let me just write it right here, in fact. So here we're in 4.1, law of sines. We're going to get the law of sines and cosines today. We'll start the next section, or maybe do about half of it. Law of sines. Yeah, actually, we will do half of it. Law of sines. What is it? Basically, it says that A over the sine of A is equal to, I'm going to write that very neatly, B over the sine of B is C over the sine of C. Like that. Or the upside down. You could do it the other way. Or you could put the signs on the top. It really doesn't matter. Either way.
As long as the little numbers are on top of,
yeah, as long as they go with A, B with B, C with C. Right, as long as they're matched up with their own letter. And what the A, B, and C are, by the way, let me just remind you in case you forgot. A, B, and C, those are the three angles. And then, remember, the angles are connected with the sides across from them. Remember that? Because in a triangle, as an angle opens up, it makes the side opposite bigger or smaller, doesn't it? It has direct effect, direct relationship to the side opposite. So as A opens up, it affects that side right across from it. So that's little a, that's why we call it that, and across from B, little b, and across from C, little c. That's how they always set these things up. A is across from A, B is across from B, C is across from C. The sides are across from the angles of their same letter. And so that's what we mean by these ratios, or these ratios are equal. In other words, let me say that in another way that might even make more sense. If you have a triangle here, let me make a triangle with a really tiny angle and a really big angle. This is a triangle. It's very clear. What's the biggest side on this triangle?
C.
That bottom. That bottom, I was going to write bottom. That is the bottom. But I mean to write biggest. This is the biggest side, right? And this is the medium side, and this is the smallest side, right? Well, across from the biggest side is the biggest angle. Notice that's the only angle clearly bigger than 90. That one's bigger than 90, and it's more than a right angle, huh? It's like 100, 110, I don't know, something bigger than 90. That's the biggest angle, which is across from the biggest side. And this is the medium angle, which is across from the medium side. And this is the tiniest little angle here, huh? And notice it's across from the tiniest side. So that's what I mean is always going to be the case in a triangle. The biggest angles across from the biggest side, the medium angles across from the medium side, and the smallest angles across from the smallest side. Because again, the angle, as it opens, affects the side across from it. So that's the idea behind the law of sines. That basically if you divide smallest by smallest, that's going to be the same thing as medium by medium is large by large. Just think about some numbers. What if I said, what if I divided, why is it doing that? 3 over 3 is the same as 4 over 4 is the same as 5 over 5, isn't it?
Right.
They're all 1. The ratio is 1. Now, I know I didn't write any signs of any angles there, but I'm just showing you the idea. Smallest over smallest, medium over medium, large over large. You're going to get the same ratio, 1, 1, 1, all the way through. That's the idea behind the law of sines. Honestly, I don't even know how they proved the law of sines. It's interesting. So I'm giving it to you like magic. I hate to do that. But it's magic to me too. I don't know. It's just, why is that true? It's interesting. As I look at it, I think, maybe I'll spend an hour or two this afternoon and I'll look at it. And then I think, no. I've got this commitment and that commitment, the other commitment. I think maybe after my children are raised. That's what I always think about these, After the kids are raised, this will be like a hobby. This will be one of many things that are interesting to me that I don't have time to look at right now. So anyway, we'll just take it on blind faith there. It's the truth. It's magic, the law of sines. Here we are. Here's question number 1. We're going to use the law of sines. First off, how do we know? I think this you probably do remember. I remember talking about this with you. How do we know that you need something new? Like, why can't we solve this using the stuff we already learned? Because there's not a right triangle. Good, right? Notice this is not a right triangle. There's not a 90-degree angle there, is there? All the stuff we've learned about, because we've solved triangles in some of the chapter 3, chapter 2, whatever it was, the last couple of weeks. We've solved some triangles, but we always use SOHCAHTOA. I'm trying to help you right now because that final's coming 2 weeks from tomorrow. And it'll all be there, all mixed up. And it's kind of hard to remember, is this or that or the other thing? So let me help you start recognizing, identification. SOHCAHTOA, what we've been doing up to now with every triangle basically, SOHCAHTOA requires a right triangle, doesn't it?
Why couldn't we create two right triangles then?
Put a line right there and make, you could. And we'll do that to prove something a little bit later. But we're going to do it with that, yeah. But if I did that, notice if I did do that, then C is not actually in either right triangle.
Right.
He's part of both. So that gets complex. It's not going to necessarily be simple.
Okay, so
And not only that, is the 81 is split. And I don't know this height. So there's just some other difficulties, basically, that come along with doing that. You could always make one, but this law of sines will be way easier than, I'm sure there is a way that you could do that, but this will be easier. So I want you to remember, so when you see this on the final, I mean, because when you do it tonight, it'll be cake, because we'll do like 8 of them right now. You'll go home and do 10 of them, or you'll start right now and finish it up tonight and do 10 of them. You'll know law of sines, law of sines, law of sines, because you just did it 10 times in a row. But on the final, or even on the exam, what's our exam? Tuesday, next Tuesday, it's going to be mixed in with other things, and then especially on the final, it's all in there. How will you recognize this and go, law of sines?
no right triangle.
It's not a right triangle. Is everybody seeing that? I want that to jump off the page for you. This is the first triangle we've basically had in the course thus far that's not been a right triangle. All the other ones are right triangles, and we had to have them right triangles because we had a hypotenuse, which is across from the right angle. We had to have a right triangle. Bernadette?
Nothing. It was just kind of an unrelated question.
All right, well, grab me later. So, all right, so let's get down to it then. So we know we need something new. We can't do SOHCAHTOA on this because this is not a right triangle. That's the big hint. Oh, use the law of sines. Okay, first off, can we find that missing angle? That'd be really easy. I think that we did do last time.
Yes.
How do we find that missing angle?
We subtract the other two by 180.
We
180, right?
no, and minus 180.
Exactly. So add these two. So let's take 81, 37, 118. I think, right? 118. Subtract from 180. So B, angle B, is going to be 180 minus 118. What is it? 62? 62. So B must be 62 degrees. There it is. Okay. So we got that was easy enough. Now, didn't need law of sines for that. But now we will jump into law of sines. Now the way law of sines works is you want to have an angle and an opposite side both having numbers to use to get you going. And that would be these two, wouldn't it? See, we know both those numbers. We know the angle and the side. So let's put those together. Oh, and what are we trying to find? Actually, I should start with what we're trying to find. What do we want to find? Let's start with B. We got to do B and C. It doesn't really matter which one you do first. I'll just do B. So we need to find the little b. So here we go. To find little b, I'm going to set up the law of sines. So little b over the sine of his angle is A, which is 6, over the sine of his angle, 37 degrees. So notice I'm not going to use all three. When I wrote, let me go back to this. When I wrote the law of sines, I wrote all three, but we're just going to use 2 at a time. We're not going to use A, B, and C. We'll just use 2 at a time. So I'm just doing the B and the 62, the A and the 37. Got to be equal. Equal fractions. So we have only one letter, huh? B is the only letter here. All the rest is numbers. So how do we solve 2 equal fractions?
Cross multiply.
Cross multiply. You guys are pros at this now. So diagonal, diagonal. B sine 37 is 6 sine 62.
Yep.
How do you, and B sin I won't be alone.
Divide both sides by sine 37.
Divide by that sine of 37 degrees. Boom. So that little b is whatever those numbers say. Oh, make sure you're in degree mode. We've been in radian mode for everything we've been doing in chapter 3, huh? So change your calculator to degree mode, because these are degree angles, as you can see. I'm getting 8.8. They just want one place around 8.8. Well, actually, we better use a couple more, because I think we're going to use that. Oh, no, we're not going to use that number. We don't need any more. 8.8 is good enough. 8.8. You getting that okay? It's how you find a side when you don't have a right triangle. Use the law of sine. Well, at least it's one way. We're going to also use the law of cosines today. It's a big day. It's always a big day in summer. We go for 2.5 hours and cover many things. All right, and now we need to find C. Can you find C same way?
Sure.
I would use the A with the A again, since they're not rounded, they're exact numbers, everything will be exact. So we're trying to find C. So C over sine of 81 degrees is A, which is 6 over sine 37. We good there?
Do we have to keep using the known side A, the known sides?
You don't have to. You could use B with B. I'd rather not use a rounded number, though, because it's a little bit inaccurate. Actually, though, in an hour or two or something, we're going to be forced to use some rounded numbers, in which case I'll just use a couple more places of accuracy. So really, there's not a rule against it. You could use it. You should throw on a couple of places of accuracy, though.
You only want 1 decimal point after?
Yeah, they just want 1 for the sides. And the angle, they just want, straight. So cross multiply, boom and boom. Get this out of the way here. What do we get? C sine 37 is 6 sine 81. C sine 37 is 6 sine 81. And divide by the sine of 37. Boom. There we go. And C equals, and then what is that? 6 sine 81 divided by sine 37. That's 9.8, and we're done. We got all the sides, all the angles. Is that good? Is that making sense on law of sines? Questions? I'll move on to another one if you're good with that. All right. So there's number 3. So now they're not even given the picture, but it's all right. We know what. We don't even need to draw the picture. We get the idea. Do the law of sines again. Well, actually, first off, you're going to find angle B, huh? So you got A and C. Find angle B. Subtract from 180. 180 total. So add those up, subtract from 180. Get angle B, and then use law of sines to find those other two sides. So, say 116 plus 30, 146 degrees. So then take away from 180. So B is going to be 180 minus 146. What's that? 34 degrees. So side B, angle B, is 34 degrees. Good. And now, how do you find side A? We'll just do the law of sines. So A over sine of A, which is 116, is C 180 over sine of C, like that? It's making sense? That's an A up there. It's like a 9 almost. Right there. And then just go diagonal, diagonal. Y'all just whipping along on that, okay? Diagonal, diagonal. So we get A sine 30. A sine 30 is 180 sine 116. Like that, we good? And then how do you solve for A? A wants to be alone. Everybody okay up to here? Everybody see what I'm doing? So I got B by subtracting from 180. Then here I'm doing A over A, C over C. Diagonal, diagonal. A says I want to be alone, so divide by the sine of 30. Boom. So what is that? I have no idea. What is that? 180 times sine of 116 divided by sine of 30. 323. 0.6. I think it wants you to run one place. Y'all get that? That okay? Getting that number? And then we can do B the same way. I'll just whip out B real quick. So B the same way, you'd go B over the sine of, what is B? Oh, B is 34, huh? B over the sine of 34 is C. I'll go back to C again, 180 over the sine of 30. Like that. Diagonal, diagonal, cross multiplies. So B, the sine 30 is 180 sine 34 degrees. Last step, divide by sine 30. Boom, so B equals whatever B equals. Two oh 1.3. Is that good? Yeah, we'll do law of sines without too much trouble. Questions on that one? So we're going to start throwing some curveballs at us after this. It's going to be a little more tricky. Not a lot, but a little bit. I think this will be easier than that last exam. I think this chapter 4 is easier. Okay, so they're going to ask us weird questions. Look at this question. I've already answered it, therefore, I'll show you how we got that answer. But look, it says two sides at an angle, so that's an angle triangle given. Determine whether the given measurement is, well, anyway, some of the words are cut off. But basically, look what they want us to answer. There's only one possible solution for the triangle. There are two possible solutions. There are no possible solutions. So what's going to happen now is they're going to change the style, the way, the form in which they give us information. And that's going to actually make different possibilities happen. We're going to have all three of these in your homework occur. There'll be a one triangle possibility, there'll be a two, and there'll be a none. Now, why? What's different? How are you going to recognize this? It's always a lot of the battle in math, especially on the final. How are you going to recognize this even on next Tuesday when you take the exam on this stuff? How would you recognize this from the last two problems we did? What is different here about the style of information being given to us?
We have two sides and an angle.
Two sides, one angle. You see, if you look back, here they gave me two angles. Right? Two angles. So I found the third angle right away by subtracting from 180. Same thing on this one we did. They gave me, wherever it is. They gave me, I don't even know where it is now. But they always did that. Wherever it is. So now, I don't have two angles. I've only got one angle. I've only got one angle. So I certainly can't find the other two angles right now. I don't know what they are. So it's a little different kind of question, isn't it? Two sides, one angle, that's what they're saying. Two sides, SSA, they call that in geometry. I don't know if you remember all that. Two sides and an angle. You don't have to do anything with all that. But anyway, two sides and an angle. What are we going to do? Well, let's just not make a big deal about it. Just do what we normally do until something weird happens.
Okay.
How about that? And it turns out something weird really won't happen this time, but it will on a couple others. What number is this problem? I can't even see on the screen anymore. All right, so question 4. I'm just going to give it a little more room here. A is 10, 8, and 60. 10, 8, and 60. 10, 8, and 60. Okay. So here we go. You know what to do. Law of signs, right? So we'll just jump in with law of signs. And that'll be A over A. So 10 over sine 60 is B, which is 8, over sine of capital B. And I don't know what capital B is. That's what I'm going to try to find. So for you could have started with the B. It doesn't matter which one comes first or second. Is that okay what I'm writing? Does that make sense right now? I'm just putting A over A, B over B. And there's one letter I don't know. The capital B. I don't know what that is. I want to find that capital B. So how do I find that capital B? Cross multiply like usual. Let's just do the same old thing until we can't. So diagonal, diagonal. So 10 sine B is 8 sine 60. Good to there. B's saying I won't be alone. What's the next step to get B alone?
Divide by 10.
Divide by the 10. Boom. Is that good so far? Sine of B equals, and this is 8. Oops, a little scribbly there. 8 sine 60 over 10. Good so far? Now, I'm trying to get the B, the capital B, the angle B. That's an angle, huh? Alone. Could I divide by the sign?
The inverse.
That's what you want to do. Yeah. This is not multiplication, huh? So we don't divide by the sign. That's why I do the whole toaster talk. I don't know if I've said that much with you. Pre-calc, I'm saying it all the time. Sign, B is plugged in there. B is plugged in there. That's not, the mistake some students make is they think of that like multiplication. That's not multiplication. That's the sign of B, not the sign times B. That's the sign of, meaning B's plugged into the toaster, kind of like. So in other words, you don't just divide it off because it's not multiplication. The way to get rid of it is the inverse function. That's why we have those. That's why we learned those in the last section. All right, so here we go. Whoops. Sine inverse of this side and sine inverse of that side. I do the sine inverse on both sides, and sine inverse is the opposite of sine. And so what happens? It cancels out here, and you just get B alone. That's beautiful. Take out your calculator for the other side, and hit sine in. Make sure you're in degree mode. Probably should still be from the last one. Sine 60 divided by 10. 43 point, I'll use a couple places, 85 degrees. Y'all getting that? Everybody able to get that? That is angle B. We've got it. We got angle B. Everybody good to there so far? Because there's like a wrinkle I'm going to explain to you. If you're good to there. You guys getting your calculators to do those tricks? 43.85. Now, here comes the confusing part. Well, hopefully it won't confuse. Well, it'll make sense of it for you. There's actually two possibilities for that answer. That's only one. The calculator only tells you one because of the restrictions. That's the hardest thing about trigonometry. It's those restrictions that we put on sine, cosine, and tangent, inverse. Remember how we had to restrict them? And we had to say it's only certain quadrants. Remember that whole thing? We had to say cosine inverse can only be in these quadrants. And sine inverse and tangent inverse is only in these quadrants. And all that kind of weird stuff. Remember all that? Well, that just never stops troubling us. And here it is as well. And you might think, where is it? Well, it's because we did the inverse. I did the inverse right here. when you do the inverse, you've got to realize that even though your calculator only gives you one answer, there really are two. You got to know even better than your calculator. There's really two possible answers. What do I mean? Well, just think with me. You know this. I don't think I'm saying anything that's surprising to you. What if somebody said, hey, the sine of theta is a half? Sine of theta is half. How would you solve that for theta? How would you get theta saying, I won't be alone? What would you do? You would do sine inverse on both sides, right? Or you would just look on the, and that would cancel out, and you get theta alone. Or you would just look on the unit circle and say, where is sine of theta a half? Let's look. Let's go together and look. We'll go here, unit circle, where are you? There it is. Whoops, I did the wrong one. What is that? Where am I? I'm lost on my iPad. Okay, let's try again. Come on, unit circle. There. All right, there's unit circle. So we're trying to answer, where is the sine of theta a half? Cosine sine, right there, 30 degrees. Yeah. And cosine sine, sine's a half at 150 also. At 150 and 30. See, two answers. There's actually two answers. Now, if you take your calculator and you hit, let's go back, and hit sine inverse of a half. Go ahead and do it. Sine inverse of 0.5. Whoops, I hit the wrong button. Sine inverse of 0.5. It's only going to tell you about the 30.
The first quadrant.
Right, you guys with me? The calculator's stupid. I don't know if you think of it that way, but it is. There's all. I'll run into people a lot and say, "Oh, why do we need math anymore? Technology handles it all." That just says to me they don't really know how things really work in the engineering world. No. Computers, calculators, they are stupid. They're just fast. They don't know nothing. They're just fast. They don't know what you're doing. They just brrr with the numbers. That's all technology is fast numbers. And so it requires an intelligent operator who knows what's really happening with that project and what this means and that means that will direct the stupid fast computer. That's what it really is. It's just stupid and fast. So yeah, the calculator's just going, well, boom, there you go. And it's just telling you 30 degrees. But we know very well, looking at the unit circle, there's another one. There's another place where sine's a half. Right? So there's another place where sine theta equals half, and there's also another place where sine of b will equal that. Well, how do we get it? Calculator's only telling us this one.
All students take calculus.
Well, now, by the way, why is the calculator only telling us this one? Well, because of the restrictions. Remember where sine inverse is restricted to be? Only him and tangent inverse are only those two quadrants. So he's like, I'm only going to tell you answers here and here. But we're saying, hey, yeah, but there's another answer over there. Yeah, and I'm not telling you about it, says the calculator. I'm restricted. I'm not telling you about that other answer. Why that? It's a long story. I told it briefly, but in pre-calc calculator, more about what. But let's just go get it now. How do we go get the other answer? We'll come back here. If I just had the 30,
The reference angle.
same reference angle. It'll always be the same reference angle in the second quadrant. Why? Because that's the other place sine is positive, right? You with me? This is positive, isn't it? This is positive. So where's the other place sine is positive? All students. Sine's positive right there. So you know your other answer is going to be in the second quadrant. It's going to be the same reference angle in the second quadrant. Well, how do you find that? Well, this is 30 degrees. I'm doing the half thing. Well, just helping you focus on the half. Then we'll do our particular question. 30 degrees. Well, what's 30 degree reference angle in the second quadrant? 150. See, it's 180 minus 30. It's 180, back up 30. So therefore, when I get this crazy 43.85, how do I find the second option that's in the second quadrant? 180 minus it. That's how you always find the same angle in the second quadrant, right? Because it's 180 back up, same reference angle. So that's long story short. You don't have to understand all that detail I went through, but you do have to know what to do now. What do you do now? 180 minus it. So let me write that out. So once you get your answer, the other option for B is 180 minus the 4385, which is 136.15. You good there? That's in the second quadrant, isn't it? That's between 90 and 180. The second option is always in the second quadrant when you do inverse sine. Now, everybody good to there? This is why there's two possibilities for B. And that may or may not make two possible actual triangles. So now let's bring our mind back. Again, the calculators don't know what we're doing, but we know what we're doing. We got a real life triangle, and we're putting angles and sides in a real life triangle. What's the total degrees in any triangle? 180. We can't ever go over that. What if we already got in A 60? So can we have 136 as another option? Bye-bye. But sometimes it'll hang around. Am I making any sense? So in this case, there's only one actual possible option. There's only one because of the 180 problem. So let me write that out. But if the total is more than 180 in the triangle, cross it out. So that's the deal, right? Plus 60 is too much, right? Because I just erased it. It's not what I meant to do. Because we already have another angle that's 60 degrees. So we can't have B being 136 plus 60. That'd be 196. As in that triangle, that's too much. So you're tracking with all this. Is that good? Are you smelling what I'm stepping in? Like they say in the South? I love that saying. That's a good word picture. Are you tracking with me that close? You good? Right? That's got to be the case. So what do you do? So long story short, what do? You do the sine inverse, you get your answer, you find the other one with 180 minus, and then you see if it'll fit in the triangle or not. If it's got room, if you're under the 180 total, great. It's a valid option. If it goes over 180, throw it away. So I'm throwing it away. So B can only be 43.85. That's why the answer to this question is there is only one possible solution. B has got to be, they want me to round it to 44. But in a minute, I'll show you one where there are two valid, and then there's another one where nothing will be possible. We'll see them all. Yeah,
So
honey.
if you add that 60, that's going to be your C angle?
No, I'm not going to actually add the 60 at all.
Well, yeah, but if we were to, like if it were, because the B is 43.85, the A
Right.
is 60.
Yeah, so you're right. So those two, oh yeah, that will be. I'm sorry, yeah, I will. That is how I will find C.
Okay.
You're right. I'm sorry, I was thinking about the 136. Yeah, you're totally right. Yeah, let's go on and find the rest of the stuff now. Yeah, that's exactly right, honey. That's exactly what we'll do. So everybody good? To there, though, I wanted to really make clear why there's only one possible answer here. You always try finding the other one with 180 minus. Why? Because sine inverse has two options. 180 minus, and then you realize, oh, can't do that because that's too much. Cross it off. So B's got to be that? Yeah. So then the rest is normal. It's like Ani's saying, we just go on and say, okay, now how do we find angle C? Well, you have to add, it's going to be 180 minus whatever the other two, the 60 and the 43.85 added together. 180 minus that, right? Whatever that is, 180 minus. I'm getting 76.15 degrees. You get that for C? So now we have angle A, 60, angle B, 43.85, angle C. And in the end, we're going to round that to 44, but don't round right now. Remember, when you're going to, I just used a rounded number, didn't I? So if you're going to use a number that's rounded, use a little more accuracy so that everything's right in the end. If you round too abruptly right now, things won't be good later. So use a couple places of accuracy. So in the end, they want me to just say C is 76, B is 44. And finally, what do I have left to find? Have I got everything? One more thing. The little c. I got to find the little c. So let me come up here. The other side. And I go, okay, C over the sine of C. What's C? 76.15 equals A over A. How about A over A? 10 over the sine of 60 degrees. Diagonal, diagonal. C sine 60 is 10 sine 76.15. Last step to get C alone. Divide by sine of 60.
So you only use the invert when you don't have the degrees.
Right. Exactly, Jose. When you don't have the angle, you don't have the degrees, you use the inverse. 11.2. Done. We got everything. Hope I'm not confusing with the 2C. This is supposed to be a small c. Whatever. The side's 11.2. The angle is 76.15.
And you can double check your work by checking to make sure that, like, the biggest angle has the biggest.
Yeah, the biggest angle should be with the biggest side, medium, medium, small, small. Yeah.
So how would you find the other C?
Yeah, you would have to use the other information. So if you had two B options, they would both lead to two C's by subtracting from 180, and then two other side C's. We'll do that in a minute. Sound like fun? Two complete options. Now that's where we're going next. We'll do a double. So that one only had one possible triangle. So here we go. We'll just crank it. This one's going to end up with double answers. Let's just crank it through, though. So start with A over A, right? 13 over sine 56 is 14 over sine B. That seemed normal enough there. Can you solve for B there? Cross multiply, and we're going to have to do the inverse sign to get rid of the sign and solve for B. Boom, boom. Like that. How do we solve for B? Divide by the 13. We get to there. And now, does it make sense that the only way we're going to get B is to get this sign off, and the way we get the sign off is sign inverse? Y'all feeling okay about when to do the sign inverse thing? Is that making sense? It's when you get down to here and you're trying to get the letter alone. That's always what we're doing, huh? Is get these letters alone. So we got to get that sign off, and we can't divide by it because that's not multiplication. That doesn't mean sine times B, it's sine of B. The B's plugged in there. So the only way to get rid of it is sine inverse of both sides, and that cancels. Sine cancels sine inverse, and we get B equals, and then try it on your calculator. Uh, 63. 63.228 degrees. That's an angle. Y'all getting that? But there might be another. There might be one that's in the second quadrant, more than 90, an obtuse angle. More than 90. This is an acute angle, less than 90. Like an acute pain. It's a short pain. Not a chronic. Right? So we're going to do the other B, the other B, which may or may not really be a valid option. I've already told you it will be this time. Last time it wasn't. How do you do it? It's always 180 minus this one, which is 116.772. Right? Is that making sense? So the question is that valid? Is that okay? Well, the only way we're going to know is if we take that and we add it to the other angle we already know about, the 56A. And what do we get if we add those two together? Is it under 180? I'm getting 172.772. So it's okay. Honey.
Why didn't we do this on the last problem?
On the last problem, we never did sine inverse. It's all because, yeah, good question. It's all because we're doing sine inverse.
I thought we did do sine inverse.
Oh, yeah. Oh, you mean the very last problem? Yeah, we did do this. Well, we didn't have a valid option, though. So on the very last problem, I did sine inverse. I got this. I tried the other one. Where is it? Other option. There it is. I did it right there. I did 180 minus it.
Okay.
And I got that, but I crossed it off. Why did I cross it off? Because I already had 60. 136, that can't be. That's 190, so that's more than 180.
Okay.
So does everybody see the difference? When you do the other, you always try the other option at first, but then you check if it's valid or not. And it's valid if it keeps the total of all angles under 180. So last problem, it came out 136.
Last problem. I thought that was C. So
Oh.
that was the other B.
Yeah, that's
Okay,
the other option for B.
Okay.
Yeah, that was the other B. Yeah, whenever you do sine inverse and you get a B, you right away then do 180 minus, that's the 43.85, 180 minus 43.85. Do the other option and see if that keeps your total under 180. If so, it's a valid option. This time, on problem number 4, it was not a valid option. Here on problem number 6, it is a valid option. The other B, 116.772, if I add it to 56, we're still under 180, so it's possible. So what that means now is we have two complete different triangles that we have to solve. There's actually two possible triangles. Making sense? I'm going to go to a fresh screen and break it into two sides and figure them both out now. But are we good? Does everybody see why I've concluded that's okay? Yes. So there's two triangles, aren't there? There's going to be two possible different triangles. I'll draw a picture maybe in a minute on the iPad about what does this even look like? Why are there two triangles here? I'll show you. There's actually two ways you can make this work. And I'll show you pictorially as well. We good to hear? I'm going to go to a fresh screen now, and we're going to finish the work for both triangles. So now, what do we have so far? In both, we're still working on question number 6 here. And we had A is 13, 14, 56. So So 13, 14, so that's going to be the start for both of them. But in one case, I've got capital B is 63.228. 228 degrees. And in the other case, I've got capital B is 116.772. 116.772. Yeah. So is everybody with me? So I've got two options now for capital B angle. They both start with the same three pieces of information, but now there's two options for capital B leading to two different possible triangles. So here we go. Let's find C over here now. C is going to be 180 minus the other two, the 56 and 63.228, whatever that is. I'm getting 60.772 degrees. And the other side, there'll be a different C. It'll be 180 minus the 56 plus 116.772. And I'm getting 7.228 degrees. See how we got the two different B options leading to two different C options? And each of those will lead to a different side C. Let's find that now. Side C. So side C, how am I going to find that? Law of sines. So C over the sine of C equals, I'm going to go A over A. 13 over the sine of 56. Good to there, diagonal, diagonal, right, to solve. This problem long enough for you? C sine 50 degrees, 13 sine 60.772. Last step, divide by the sine of 56. Boom, C is whatever it is, 13 sine 60.772 divided by sine 56. I'm getting 13.68 for the side little c. Now over here, let me do the same thing. 7 point, little c, which I don't know, over the sine of 7.228 degrees is A over A. 13 over the sine of 56, diagonal, diagonal. What do we get? We get C sine of 56 is 13 sine of 7.228 degrees. Last step to get it alone is to divide by sine of 56 degrees. Boom, little c is 13 sine 8 divided by sine of 56. I'm getting 1.97. Whew. There it is, two complete triangles.
That one's like a sliver of a...
Now I'm going to draw them. Are you good getting those answers? Is that making sense? Let me draw those two triangles to show you what's even going on there. So A is 13, B is 14. Yeah. Okay, let me draw them. So the triangle on the left, and they both have 56, right? So it's going to be a 56 degree angle. Oops, I never make my sixes very well. Angle A here. Same thing here, no difference at all. It starts off exactly the same. They both have some parts that are the same. Angle A is the same in both cases. And side A is 13, side B is 14. So this is 14. Let's make it a little longer. There we go. This is 14, this is little b, 14. And this is, same thing, little b, 14. So those, and then how long little a is? How long is little a? Little a is 13. Little a is 13. And how do I do this? Little a, you're 13. So little a is 13. And yeah, so there's two options. Little a is 13, so it can kind of come far. Well, it's more like this, and be 13. This is little a here. And let me draw it back a little bit, more like that. Little a is 13, or it can shrink way down, kind of like this. Little a is 13, and oops. See, those parts are all the same, and the parts that are different is C is 61. C is 61. This is C here. A, B, C, B, C. What was C? 61 degrees on that one. On the other one, it is 7 degrees. See, it's real tiny here. 7 degrees. And then side C is 13.7. So 13.7 there. That's little c. And the other one is only 1.2. There. See how those two triangles have some parts that are the same, some parts that are different. These guys match, and these guys match in both triangles. They both have the bottom side the same, the left angle the same, and the top is 13 in both cases. But there's two different ways to complete that triangle with that information. Do you see that? There's two different triangles that have the same AAB, don't they? There's two ways to do that. There's not always. Sometimes when you specify an A, and a B, there's only one way that can be completed. Sometimes there's two ways. Sometimes there's no way. Let's see that next. So that's a picture of what just happened. See how this one came out with a really tiny angle and a really tiny side? There was a way to complete that. All right. What's going to happen on this one when you hit the buttons on your calculator? You're going to get an error. That'll let you know that's not even possible. So let me write it out. So 8.4, this is number 7. Little a is 8.4. 3417. Did I get that right? Yeah. Okay. So let's just dive in. Just dive in. Do the normal thing you always do with law of signs. And you'll see when you go to do the sign inverse, you hit the button, it'll go error, not happening. And then you know there's not even one triangle possible that fits that initial information. That's impossible information. You can't really make a triangle out of that. That won't be true.
They won't connect.
It won't connect. It won't connect. Exactly. The third side won't fit up. Not at the angles they've given. Yeah. Or at the angle they gave. Right, so let's dive in. So it'd be A over A. So 8.4 over sine 17 is 34 over sine B, right? A over A, B over B. Two equal fractions, A over A, B over B. And then, what do we do from here? Cross multiply. 8.4 sine B is 34 sine 17. How do we solve for B? Divide by the 8.4. Boom. Sine B is 34 sine 17 degrees over 8.4. We good to here? How do I turn this thing? How do I get B alone?
Inverse sign.
Yeah, the way to get the sign off of there is inverse sign. Inverse sign right here. These cancel. Gets B alone. I'm saying error. Do you guys get an error when you do that one? Error. Not even possible. That means no triangle possible. Meaning what they did is they gave you some angle 17 degrees, which is really pretty small. 17 degree. And they made A only 8.4, and they made B so long, B's like 34 way down here, that there's no way to make these guys connect up. There's no way to make those. You can't really make a triangle out of those specifications. The bottom's so much longer than the top, and they got a small angle here. It just doesn't work out. That's not even possible in a triangle. That's what our calculator's telling us. Is that good? Ready for a break? You guys look like you're ready for a break. Let's take a 10-minute break. We'll come back and finish up the section and go on into log cosines. So question number 8. We're almost done with this section. We've been through the worst of it. Question number 8 won't be bad. They're asking us to find the area of the triangle. Now, do you realize that's a completely different question than we've been answering up to now? Area. That's space in the middle. That's not sides and angles, right? Get a little fresh air in here, maybe. Oh, it's noisy up there. All right. So to find the, I'd open the window, but we're in the basement. All right. So to find the area of the triangle. Did you guys hear those gas announcements earlier today?
No, I was in the cafeteria.
Okay.
Yeah, I got emails about it.
Yeah. Yeah. All right. So find the area of the triangle. So notice the question's completely different. That's what's often hard in, exams is keeping everything, they all starts to look alike, huh? So does this one seem different to you now? It's completely different from the first 7 questions. They want to know area, space in the middle of the triangle, not side lengths, not angles, right? All right, well, how do we do it? We need a completely different formula. So here it is. Area of a triangle is 1/2 AB sine C, or 1/2 BC sine A, or 1/2, what else we got? AC sine B. In other words, it's 2 sides and the sine of the other angle. Do you see the pattern there? Math and science is about patterns. So you don't want to just try to raw memorize those. Look at the pattern. Notice, they always have a half. They have an A and a B and the sign of the other letter, huh? Or a B and a C and the sign of the other letter. Or an A and a C and the sign of the other letter. So it's any 2 sides and the sign of the other one, huh? Does that make sense? The official way it's written out is the area equals 1/2 times side 1 times side 2 times the sine of the angle between the sides. I don't know if that helps, makes it any simpler. But it's 1/2 times side 1 times side 2 times the sine of the angle between them. That's what I'm writing up there in those formulas on that. Clarence?
The answer is supposed to be square units, so square yards. So does the unit gonna matter every time, or yard is like the definitive thing for the area?
Yeah, so for area, it always is in square yards. Like you go buy carpeting, you buy it in square feet or squares because you're talking about actual squares. So area. Whereas if you bought new tack strip, like this black stuff down here at Home Depot, right? That would just be length. Right? So area, if I bought new carpeting here, area is in square units. That's what it is. It's actual squares. Square yard, square. We don't have to do anything with that mathematically. That's just what area is. It's square. It's how many squares. So a square yard is something that's a yard wide by a yard tall. A square is about 3 feet, 3 feet. About this big. Square yard, right? They would say how many square yards or square feet are in here. So that's just the units of area. All right, so let's do it. So this should be pretty simple. This will be way simpler than those others. It's 1/2 times one side times the other side, so times 6 times 5 times the sine of the other angle, 33. Hit the buttons on your calculator. So I'm getting 8.169, whatever. I don't know how, round to nearest square of this one, 8. Did you get that? Eight square units. On that. Is that making sense? Using your triangle there, your calculator. Questions on that one? Good? All right, I'm going to move on. I want to show you where that formula came from. I don't like just writing the area formula up there like it's magic. Let me derive that one for you. Let me show from where it comes. Is everybody good with using it? See how that's a totally different question on the exam, area? Okay, now where's it come from? I bet you know something about the area of a triangle already. What do you know from your algebra days about the formula for the area in a triangle? I don't mean this new fancy formula we got. I want to show where that comes from. But just tell me the basic one.
Isn't it 1/2 of length of a side?
What is it? Anybody know?
Based on height,
Base.
divided by 2.
Yeah, half base times height. Half
That's what I was trying to get at.
of base times height. You heard of that one before? Area of a triangle is half of base times height. You familiar with that one? A little bit? So that's the area of a triangle. Now, so how can we go from that to that special one they gave us with half, 2 sides, sine of the angle in between? I mean, where's that come from? How'd they come up with it? It's actually pretty easy.
We can do like 1/2 times the sine of A, 1/2 times sine A sine B sine of the other angle that you have.
Right, but where'd they come up with that? So that's what I want to show now. So I want to start with this one and arrive at that one. So with a couple simple steps. First off, we have to be really clear what base and height are. Even though we throw those around, base and height, base and height. We all know what that is. Well, let's be super clear. If I was to measure my height, what would I do? Start with a tape measure here, and what if I went diagonally down to the ground to measure my height? I'd be like 8 feet tall. I'd be ready for the NBA. Call up the Lakers. I'm going to join LeBron. You know, they're going to want me for like a title. Maybe 51-year-old math teacher. Maybe not. But 8 feet tall, that's tempting. Right? That isn't height, is it? You can't go diagonally down to the ground. How do you do height? Straight down. Height is straight down to the ground, isn't it? So therefore, if I want to do height of this triangle, if this is the base here, the bottom, right? Base is the ground floor. Where is height? Is it the left side or the right side? Neither. It's straight down at 90 degrees. That's what height means, huh? Anything else is not height. We all know that, right? You got to measure height straight down to the ground, don't you? So if this is the base and this is the height, so now let's find the area of that triangle. By putting that height in, notice what I've made. Right triangle. 2 right triangles. One on the left, one on the right. Now I'm going to go in here. Let's say this is side angle A, angle B, angle C. I'll take this angle here. Now this triangle right here is a right triangle, isn't it? That's a right triangle. So I can use what? SOHCAHTOA. Right triangles, you can use SOHCAHTOA. Okay, I'm going to show you how they came up with it. So now, what's the sine of angle C here? This angle C. What's the sine? Opposite over hypotenuse. Opposite over hypotenuse. Well, is that going to help me? I thought it would. It's not looking so good now. What am I doing here? I'm doing something crazy wrong. I was just cranking along so well. Opposite over hypotenuse. Little h over that side.
What's your basis of numbers?
Base times height. Yeah, the base is b. The height is h. It's all good. Sine of c is the height. Okay, no, we're good. I'm sorry. We're good. The sine of c is the height. That's the opposite, right? It's the height of the triangle, right? The little h. Hope I'm not confusing the little h with the hypotenuse. This is hypotenuse. Let me just write it out. So little h is the height, right? That's straight down to the ground. That's the height. Over the hypotenuse. Now, what is the hypotenuse? It's little a. It's across from the a, right? Over little a. We good there? Everybody, I'm trying to erase that, make it more clear. Is that good? Sine of c is opposite over hypotenuse. H over little a. Good. How do I solve that equation for h? Put this over 1, diagonal, little a sine c is h. Good. And now what is h? I want to plug in right there for h. Area is 1/2 base times height. What's height? A sine c. There's their formula. There's the formula they just gave you. 1/2, 2 sides, sine of the other angle. That's all they did. So that's not on the test. That's no extra charge. That's a derivation. That's where they came up with that formula. They just started with the basic one, half base height, put the right angle in there, did a little SOHCAHTOA derivation. It's
Wait,
not.
was this for number 9?
It's proving number 8's true.
Oh.
It's not required. Sorry, am I confusing you? Yeah, no, this was just, I was just showing where the formula came from. Every now and then I just, I got to show where things, I don't like just math is like magic, right? I wrote this formulas up here like they were just magic. I wanted to show you where they come from. So, all right, I hope you enjoyed that. But it's not in the test, not required. Let's go to number, all right, so can you find the Leaning Tower of Pisa here? Can you find that B? How tall that tower is? See if you can find that using the law of sines. It's not a right triangle, is it?
No, because it's leaning.
Because it's leaning. If it was straight up, we could use the right triangle SOHCAHTOA stuff. But since it's leaning, we don't have a right triangle, we got to use law of sines, don't we? So crank out law of sines there.
We have to find the angle C first.
Exactly. So first you got to find the missing angle. Good job. What's this missing angle? You got to take these two angles, add them up. 84.7, 47.4. What is that? 132.1, I think. Did I get that right?
Did you get 47.9? Oh, I got to find it.
Okay, and then, yes, C will be 180 minus the 132.1, which is 47.9. We're doing that right?
47.9.
Okay, so C is 47.9 degrees. Good, now we have angle C. So now, can you find side little b over there? Can we do that? Side little b? Law of sines. So I'm going to go B over B is C over C. So B over sine 47.4 equals C over C. C is 185 over sine 47.9. How are we doing? B over B is C over C. Am I losing you? Is that good? Just normal law of sines, right? I found C by subtracting from 180, adding up the other two to subtract from 180. Then I just set up law of sines, B over B, C over C. And then cross multiply, diagonal, diagonal. B sine 47.9 degrees is 185 sine 47.4 degrees. B is saying, I want to be alone. So what do we do?
Divide both sides.
Divide by sine 47.9 degrees. Boom. Hit the buttons on your calculator. 185 sine of 47.4 divided by, whoops, I forgot sine down here. What am I doing? I'm getting hasty. I'm getting 183. I don't know how much they want me to round. 0.5, whatever they want you to round on that. Did y'all get that? Is that good?
I want you around to the nearest integer.
So 184. 184. Yeah, so did y'all understand what I was saying about when you're doing your homework in this section? Use 2 or 3 more places of accuracy along the way so your rounding is correct at the end, right? Never round too abruptly in the middle of the problem. Always use 2 or 3 on that. Right? Is that good? Everybody hearing me on that? So always use, because that'll really frustrate you in the homework if you're not using enough. You do all the right work, basically right, except it's one little rounding thing off, and it'll say no. Math Excel's not too forgiving, is it? It'll just go no. So use 2 or 3 digits, 2 or 3 decimal places along the way and then round your final answers. All right, that's enough.